Hello, Mr. Novak here, and following up a request from a student to look at exercise 8A, question 16. Those who know me, I always bang on about how we need to draw. When it comes to worded questions, you'll usually have to draw 3 times, and this is a great example of that. The other thing I always like to get the students to really appreciate about Pythagoras is the triads. We all know the classic 3, 4, 5, and from that we can build on others. And when you do, you'll find that there's a pattern, and if you can remember that pattern, this question is a no-brainer. So let's have a look at the question. A ladder rests against a vertical wall with the top of the ladder 7 meters above the base. So the first thing, you just draw the situation. By doing so, you're beginning to understand um, what possibly, because it doesn't say use Pythagoras. You just think it's Pythagoras because it's a topic, but in the exam, when you draw it, you recognize that there's a triangle, and we're going to make an assumption that the wall and the floor or the ground are right angles to each other, and so yes, it's a possibility of doing Pythagoras. We're told the ladders are 7 meters up the wall, so there's one known value. But that's all we know. So, we then are told when the bottom of the ladder is moved one further by 1 meters. So, in other words, what we were saying is we don't know what this length is, nor the length of the actual ladder itself. So, let's follow the next instruction. When the bottom of the ladder is moved 1 meter further away from the base of the wall. So, let's draw that again. So, this is my second drawing. So we now have the bottom of the ladder has been moved an extra meter. So if we call this x, we would call this x plus 1. And here's the trick. Got to read questions carefully. The top of the ladder, there's the bottom, 1 meter further away from the base of the wall. The top of the ladder rests against the base of the wall. In other words, that now is down the bottom. So in actual fact, the ladder is now on the ground. And we now know that the ladder must be x plus 1. So we now go back to our original diagram. We don't know how far from the base the ladder was placed, the bottom, but we now know that the ladder is x plus 1. And as you can see, we only have one pronumeral. So therefore, we only need one equation, which is obviously going to be c squared equals a squared plus b squared. So substituting c squared equals a squared plus b squared, we end up with the hypotenuse. So don't forget to recognize that that's the opposite. The other two lengths can be, which are C, A and B. And so we have x plus 1 all squared. Ooh, that looks like a perfect square. You remember how to expand perfect squares? A is x squared and b is 7 squared. So expanding and simplifying, we end up with x squared plus 2x. Remember, square the first term, square the second term, always positive. We knew that from completing the squares. And multiply two together and double it. Also, we learned that from completing the squares. Equals x squared plus 7 squared. I'll pause for a tick while I scroll the page down. Right, so we end up, let's get rid of that squared term there. So we subtract squared from both sides. Um, that's minus x squared from this side, minus x squared from this side. We end up with 2x plus 1 equals 7 squared is 49. Get rid of the plus 1, so it's minus 1 from both sides. That gives us 2x equals 48. Therefore, x equals 24. And so, therefore, if we draw that triangle, we now know that that's 7. X was 24, and that is 25. And I think a lot of students will recognize that's the Pythagorean triad 7, 24, 25. And we should have recognized that right at the start here when we knew that the two lengths were only 1 unit or 1 meter difference. Other common triads are the 5, 12, 13. Notice they are 1 unit difference. The 3, 4, 5, 1 unit difference. The 9, 40, 41, 1 unit distance. So hopefully that helps you, and maybe you can now learn to apply it to this one here. Let's go back to question 12 of exercise 8A. I've started to draw it, but I've stopped at one of the sides. And remember, normally we might call this y equal the y side and the x side, but because we have two pronumerals, we would need two equations, and we only got the one Pythagoras equation. So read instructions and see if you can do something with that y. In other words, replace the y with something that's going to be like the previous question, only one pronoun. Okay, thank you very much.